Okay, so this is the binomial theorem, and what it states that is for a plus b to the n, this is equivalent to a to the n plus n choose 1, a to the n minus 1, b to the 1, plus n to the n chooses 2, a to the n minus 2, b to the 2, and then so on until you end up with b to the n again. So you might be wondering, what does this mean? Well, this is n chooses r, and which in this case r equals 1. So there's a formula to this, basically saying n choose r equals n factorial divided by r factorial times n minus r factorial. So with this information, we can make a general term. So this general term goes like this. You have t, and then you have r plus 1, which equals n choose r, and then a to the power n minus r times b to the r. And this right here basically is r plus 1 is what position the term is in. So let's say if r equals 3, then it would be t, and then the subscript would be 4, because r plus 1, 3 plus 1 is 4. And this means that 4 is the fourth term. So let's say this is the first term, second term, third term, and then this is the fourth term. So this 4 is talking about this fourth term right here. So I usually would say nth term, but that would get confusing because there's already an n here, which is the total number of terms, or the exponent. So that's why I just showed it like this. Okay, so now with the binomial theorem, let's do some examples. So I wrote down the general term here, which is t sub r plus 1 equals n choose r times a to the n minus r times b to the r. And then the formula for n choose r is n factorial divided by r factorial times n minus r factorial. Okay, so first off, it says we have to find the first three terms of this binomial expansion, 2x plus 1 to the power 11. So let's make some variables, starting off with a as 2x, and then b as 1, b is 1, and then let's say n equals 11, because that's what it's getting. That's what the binomial is getting raised to the power of. So 2x plus 1 to the power 11 is gonna be, so the first term is always gonna be a to the n, and we know that a equals 2x and n equals 11. So the first term is 2x to the power 11, and make sure that the whole thing is raised to the power 11, not just x. And then the next is n chooses 1. So technically this is n choose 0, but anything choosing 0 is always going to be 1. So that's why n choose 1 is the next thing after 0. So since it's n and then r equals 1 here, we can say a, again, 2x. All of that is going to be raised to the power. Also, n equals 11, so we know that already. 11 minus r, because in this general term, it says a is raised to the n minus r, and n in this case is 11, r equals 1, so 11 minus 1 is 10. And then that is multiplied by b, which is 1, and then b is raised to the r, and in this case r is 1, so it's just b to the 1. And then now the last term, or the third term I mean, is 11 chooses 2. And then it's going to be 2x to the 11 minus 2, which is 9. And then b to the 2. Or I mean, b is just equal to 1. So you can just say 1 to the 2. An easy way to remember how to put the exponents is that it should always equal to 11. So in this case, 11 is already equal to 11. And then here, 10 plus 1 is equal to 11. And then 9 plus 2 equals 11. So just note, and also another easy way to remember it is as the exponent of a decreases, the exponent of b increases. So you see how here it says 11, and then 2x is to the 10, and then 2x is to the 9, and then if we keep going, it's going to be 8, 7, 6, 5, etc. And then b is basically here, b is to the 0, but that's equal to 1. So then here, that's why b equals 1, and then b equals 2, and then it's going to be 3, 4, 5, 6, etc. Okay? So as a's exponent decreases, b's exponent increases, and both of the exponents have to equal 11. Okay, so now this problem is a little different. It asks for just the sixth term of 2x plus 5 to the 15. So technically you could just find the first, second, third, fourth, fifth, and then find the sixth term, but that takes too long. And we don't have that time, and it's also inefficient because what if they say find the 38th term, and if this was higher, like find the 38th term, you're probably not going to find the first, second, third, fourth, fifth, all the way up to the 38th term. So an easy way just to find the sixth term is by using the general term once again. So also again, let's make the variables. So a equals 2x again, b equals 5, and then n equals 15 because that's what it's raised to. And now, since it asks for the sixth term, and in t sub r plus 1, remember I told you this r plus 1 is the position of what the term is in. So since we're finding the sixth term, r plus 1 equals 6, and then if we subtract 1, we know r equals 5. So we can just add that here. R equals 5. And if, let's say, they were asking for the ninth term, you set r plus 1 equal to 9, and that would be r equals 8. But just remember, it's not, r doesn't always equal 1 minus the sixth term. So don't just make like a general idea for that. You always have to put this formula in, r plus 1 equals whatever it is, because it could be different sometimes. Okay, so now we have our 4 variables. We can just plug it all into this general term here. So we have t, and we know r equals 5. So 5 plus 1 is 6, equals, and then we have n, which is 15, and then 15 choose r. So r equals 5, even though it says here it's 6, but remember it's r plus 1. So r equals 5, and then a, which is 2 to the x, or 2x, I mean, and then that's raised to the n minus r. So 15 minus 5 is 10, times, and then b is 5, and then it's b to the r, and we know r equals 5, so it's going to be 5 to the 5. And we can check because both of these exponents add up to 15, and this is the sixth term. So also, you can expand this, or simplify 15 choose 5 by putting it into this formula, and you can simplify 2 to the 10 times x to the 10 times 5 to the 5, but generally it's okay if you just leave it in this form. Most people accept it that way, but just saying you could make it bigger and write it like the full thing, like expanding it. Okay, so the last example we have here is find b, this right here, if negative 280 is the coefficient of x to the 4 in the expansion x plus b to the 7. So this is a little more complicated and we have to do a little more stuff. So again, let's start with the general term. So let's start by saying a equals x. Let's say a equals x. And then b equals b. And then let's say n equals 7, because that's what it's raised to. 7. And then let's just put it into the general term. So t, and since we don't know what r is yet, we can just say r plus 1 equals 7, because n equals 7. So 7 choose r times a, which is x to the 7 minus r, times b, which we don't know yet, is b, and b to the r. So now we have the general term, and now to find b, let's use it. So what they're saying is that x to the 4 is multiplied by negative 280. That's what the coefficient is. So first let's start off by finding r. So since they're saying x to the 4 is what we're trying to see, we can just say x to the 7 minus r, x to the 7 minus r equals x to the 4. So since the bases are the same, we can cut those off, and we just have 7 minus r equals 4, and then r equals 3. So we can just put that in here, r equals 3. And then now what they're saying is that negative 280 is the coefficient. So we have r equals 3. Now if we substitute r equals 3, we have t 4 equals 7 choose 3 times, and then x to the 4, and then b to the 3. So now we can just say this and this are both equal to negative 280, because those are the coefficients of x to the 4. And we're not including x to the 4 is because they're saying coefficient. That's what's important about this question. So now we can just say 7 choose 3 times b to the 3 equals negative 280. And then 7 choose 3, let's put it into this formula. We have 7 choose 3, 7 factorial divided by 3 factorial times, and then 7 minus 3, 4 factorial. So, and then when we simplify this equals 7 factorial, which is 7 times 6 times 5 times 4 factorial, and then all this divided by 4 factorial times 3 factorial. So we can cut these two off, and then we have 7 times 6 times 5 divided by 3 factorial is 3 times 2 times 1, so that's just 6. We can cut these two off, and this equals 35. So now we can put 35 into this. So we have 35 b to the 3 equals negative 280. And then if we divide 35 on both sides, we have b to the 3 equals negative 8. And then if we take the cube root of both sides, you'll get b equals negative 2. And then we'll box in our answers as b equals negative 2.